Good morning, students. Today we will talk about in detail about the flammable and combustible liquids. I think we already have some information about these flammable and combustible liquids in the previous lectures, but this is a very short lecture, but it is giving like more important information about these two flammable and combustible liquids. So we already know about the flammable liquids. Those liquids, those having a temperature like or the flash point temperature below 100 degrees Celsius. So those liquids are called or fall under flammable liquids. But sometime if there is a mixture of different liquids, then this temperature range will be changed. For instance, if the total volume of that mixture is make up like 100 or 99% or more of total volume of the mixture. So due to the mixing of different liquids, then their flash point temperature will be changed. So in this diagram, you can see, I think in the previous one lecture, we mentioned this color coding system, and in detail, we mentioned what is fall under blue color and what fall under like in yellow as well as in the red, and there are some special hazards those fall under black or the white one. So here you can see in the red one, although there is a four different ranges like 0 to 4 degree, but this fall actually the flammability hazards so fall under like this 4 number color like the red color in the chart system. This slide shows the class of flammable liquids. It has a single class 1 liquids, and their subcategories are class 1A, class 1B, and class 1C. So these subcategories or subclasses are, although this is a major like one class, but it divided upon the depending on their flash point temperature as well as their boiling point temperatures. So Class 1A, they have less than 73 Fahrenheit flash point temperature and less than 100 Fahrenheit boiling point temperature. So while the liquids of class 1A have less than 73 Fahrenheit flash point temperature, but their boiling point temperature is equal or more than 100 Fahrenheit temperatures. Whereas the liquids or the flammable liquids, those fall under class 1C, their temperature ranges are a little higher, so it could be like equal to 73 or like greater than 73 and less than 100 Fahrenheit degree, and they have all boiling point temperatures, so they are more like a kind of stable. And here you can see the different examples of class 1A flammable liquids, then class 1B flammable liquids, and then class 1C flammable liquids. So you can see all these different chemicals being used in the lab, for example isobutyl alcohol, mineral spirits, and these are like also xylene. And some labs also contain like octane and methyl ethyl isopropyl, like these alcohol. So these chemicals are mostly like in I think the lab one or two are they are being used. So most of them, or might be some of not, but like most of them, these the flammable liquids are being used into the different labs. The second category is combustible liquids. So these liquids having a flash point temperature higher than 100 Fahrenheit. So they are divided into two classes. So class second, and then of course class third. So class second is only single category. So they have flash point temperature greater or equal than 100, and of course less than 140 Fahrenheit or equal. And the second subcategory is class third A, then class third B. So class third A have like equal or greater temperature of 140 and less than or equal to 200 Fahrenheit. And class 3B, so they have higher temperature, flash point temperature greater or equal to 200 Fahrenheit, more stable. They need a higher temperature. And here you can see the different examples. So here these combustible liquids have the different examples, but might be like all these the liquids are not available or not being used in the lab, but in some other domestic life we are using. For example, these fuel or like diesel or oils, so they are being used in the domestic life. So it's very informative, so at least we understand about these things. But for example, here you can see the glycol, glycine. So these are of course being used in the lab conditions. Okay, and some other other oils are also used in the labs, mineral oils means or maybe like linseed oils like in agriculture stuff. Okay, so these are the different combustible liquids with the different flash point temperatures as and their classes. Here in this table you can see like just according to the flash point temperatures and then boiling point temperature, just giving more clarity about these combustible as well as the flammable liquids. So you can see of course they have a single class like flammables 1A 1B, while combustible have two classes like the 1, 2nd and 3rd, right? So these are according to their temperatures, so they are just kind of the more explanation about the according to the temperature range they are division. So here this slide is very important, so it will give us idea about like at which temperature, like in the which situation like the explosion happen, or if there is the different chemicals. So for instance, um, the minimum vapor concentration by percentage in which a liquid can form an ignitable mixture in air is called a lower explosive limit. So there are two types of limits: lower explosive limits as well as upper explosive limits. Okay, and in lower explosive limits, there is the vapors or the vapor concentration by percentage is of the any liquid is minimum which it can ignite. Okay, uh, but it's below the threshold. And in the upper limits, the vapor concentration by percentage is higher, although it can make ignitable sources, right? But this concentration is too rich to suppose the combustion. But what is the explosive range? So the explosive where explosion happen. Okay, so this range is very important to understand. So while we are talking about this and this range, explosive range, so we need of course to understand this one. So one is like the lower range and one is a higher range. Okay, so both ranges are not good to make explosive range or explosion. Okay, even I think in the next slide it will be more clear when I will show you some the diagrams. So but at the moment you can understand the range, explosive range is that is fall between the lower as well as upper explosive limit is called explosive range. Okay, if a source of ignition such as whatever the spark, electricity is present, an explosion may occur. So when occur, so when this explosive range is fall under that situation. If there is a the lower explosive limit or the higher explosive limit, then there is no explosion. Okay, so in between these. So let's come to the next one. So here you can see uh, one of the example. So for example, this is a 1%, 0% to 20%. So you can see this is the range. So for example, 5 to 15 in between. So the 10 is ideal, right? So this is the ideal situation where explosion can happen. And of course, there is a if any liquid chemical, they have like a higher explosive limit, and of course then there is no explosion. And if there is a lower limit, then again there. So what happens? So this is the same rule that fall for the when we are talking about like suppressors or like fire extinguishers. So here you can see what is the difference, because here the vapors the vapors of the liquids will be less. Here it's like 1%, 2%, 3%. So vapor limit is less, but oxygen is higher. Oxygen is higher because the vapors in the the density is less. But here you can see 15 to 20%. Here is a vapor limit is higher, that's why it's like a higher limit, right? So that's why we call it a higher limit. So oxygen is less. So here oxygen will be less, but the vapor concentration is higher, so that's why explosion not happen. So this is the ideal situation where ideal like for example, if you remember the triangle in the last lectures, we cover about the fire hazards. So in that triangle there's mention oxygen, fuel, etc., right? So ignition sources. So if all these three things are available, then there will be a fire, or the fire hazard or fire happen. And here there is less oxygen, so it cannot explosive. So although there is a high concentration of the flammable liquids, so or any combustion material. So let's here is a more clear. So this is just an example that I just want to show about the gasoline. This is a very common. So gasoline, here you can see this is the ideal limit, so where explosion can happen. But here is the lower, because here you can see too less fuel or hydrocarbons that can catch fire. Okay, but of course here is a higher oxygen, and here you see too less air, I mean like less oxygen. So that's why, although the gasoline is higher, you see the gasoline is very higher, but it will not catch the fire or not like explosion happen. So this is really very important to understand about these levels, low and high combustion, as well as their limits. Whenever we're talking about the flammable and combustible liquids, definitely we need also to concentrate about the storage of these flammable, and combustible liquids. Of course, this is a necessity whenever we need to use. So if we have the stock, so we can use them. And meanwhile, their storage is very important, and it's very properly managed, and because it is a main source of fire hazards. And of course their maximum quantities we can store, like for example in the cabinets or inside the storage room. And this is, we have to follow like a certain protocols, and then of course we can of course avoid like a fire hazards. So for that purpose, of course, the glass and the container type is very important, as well as like according to their container type or the class, that particular container contain a particular quantity of that liquids. For instance, you can see like class 1A liquids containers, they can contain maximum 25 gallons liquids. And similarly class 1BC or like third second, the second C or like a third C liquids containers, they can contain 120 gallons liquids. Whether this is a flammable or combustible, it's okay. But of course, according to these classes, we can see like which is this one the liquids. So if we go back, like we already cover about the classes, so we can see like which is this liquids. And similarly class 1B, 1C, third liquids in a single portable so a tank, so they can contain like 120 gallons. So sometimes these tanks are different than these containers. Okay, so they're that's why they can contain like the same amount of liquids into that particular the containers or like the tank. If we are talking about maximum quantities inside the flammable storage cabinets, so then of course we have to make storage according to the number of class and with their quantity. For example, class 1 or class 2nd liquids can only be stored like 60 gallons, and class 3 only 120 gallons. So it means if we want to make like storage inside or outside, for example in the cabinet or in the particular or certain like a storage area, so we can only store class 1 or class 2 liquids 60 gallons, not like 100 gallon or more than like 60 gallons. And similarly at that particular area, so we can store like with class 1, class 2 and class 3 120 gallons. So class 3rd, so we can add 120 gallons liquids, while class 1 and 2 60 gallons. So this is a total into that particular one area. So you got my point. So in one area, so if we have more like liquids, for example flammable material we want to store, so then we have to organize another area, okay, into one particular point or on one particular site. So we can have only like a storage of this limits. Okay, and similarly, if we have maximum number of flammable storage cabinets, so how we organize these the cabinets, so there are also particular like a distance areas, like if we want like a multiple storage cabinets. So for example, non-sprinkled areas, it should be like 3 per area, per fire area. Non-sprinkled area, cabinet separated by 100 feet, so like one cabinet, and then second mean like after 100 feet, and 3 per each 100 feet travel distance, of course. The it should be like a 3 per each 100 feet of travel distance. So this is the distance they is mentioning, automatic sprinkle system, so this should be like a 6 per fire area. Okay, so this is might be like in the labs we don't need all these things, because if you see like in the previous classes, when we're talking about the different classes of flammable materials as well, so then there's some examples are like gasolines or like other fuels, so they are not like being used in the lab, but of course in our domestic lives. So this is all organization for, of course, for the for all those the flammable storage cabinets, or like the chemicals. Okay, so you got my point. So this is, I think, is very obvious. Transferring of flammable liquids into the small devices, into the small containers. This is very sensitive issue, because if you have liquids in the big container, then how to transfer into the small containers. So the best example I can give you about the gasoline. You see, like in the gas station, you see or you observe, like whenever we go, like we will take our car and we can get like the gas. So those are the particular the devices used to produce the transfer the gasoline into our car. So this is one example, but of course, if there is like these liquids in the lab, so we have certain devices, so those can be used. And secondly, for instance, for the big sources, this is really important uh, to to make storage of those flammable liquids in into very careful way. For example, here you can see the liquid transfer shall be through the devices drawn through the top of the drum, or by gravity through an approved self-closing valve. Transfer by air pressure prohibited, of course, to avoid any hazard. And also the containers from which flammable liquids are dispensed are to be grounded. So you see, like in the petrol pump or gas station, so they have because big source of flammable liquids, right? So they are grounded and bonded to avoid fire due to static electricity. So this is so this is a very important they should be like you understand what is the static electricity. So static electric current or static electricity is that is produced uh, due to friction, due to the friction. So for example, during the winter, when we have more dryness, and if we touch even the door handle or even some cloths, so then we feel some static current or spark. I hope everybody can have experience or can have visualize this one. So that is called as static electricity or static electric current. So that is produced actually due to the friction. So this is very common while we are making like a comb to our hair. So we can observe like in the winter, especially due to the dryness. So of course they are one of the sources of the dust particle, or the other particle can make this static electric current, and then of course it can catch the fire. So flammable liquids are of course can only be poured or dispensed or transfer into the safety cans. So this is big, these safety cans. So these are special cans. We cannot use like the normal cans to take flammable liquids. For example, we are using a water bottle, empty water bottles or empty soda bottles, like we cannot use those. Those are not actually the safety cans. So if you saw, I think everybody has experience about some gasolines or some like the oils, whenever we get change oils of our car. So you see that are particular cans. So those cans are safety cans actually. So if we need like any chemical even in the lab, for example, so we can use like those kind of safety cans. And secondly, in domestic life, if you need some, of course, gasoline, so use those particular safety cans. Don't use like the normal, for certain reasons. Maybe sometime I observe like some of the people like they are doing barbecue and they're using like the simple cans for their the flammable liquids. So this is not good. Always use these safety cans. In this slide, we are mentioning about the handling of these flammable liquids at the final points, and here also you can see we were talking about how we can drawn or we can dispense the flammable liquids into the particular cans. So we can use these means through closed piping system as we use in the gasoline. From safety cans, we can transfer like liquids from one place to the other by using those safety cans, and of course by special the devices. So those are used, for example, in the labs, the pipettes for particular the flammable liquids. Okay, so this is about the pipette. This is about like we can use in domestic lives. So of course the handling at the final point where we are going to use is very important to keep like always in the store in the specialized store like a containers. Okay, so this is of course provide like a maximum support or the surety about that it will not cause like any explosions. Okay, so because there's less chances of leakage of these safety cans or like these safety tanks. During transfer of different flammable liquids, it's better to use the select the place where is adequate ventilation, and of course there should be like no source of ignitions, so that will not like catch fire during the transfer of flammable liquids, because of course there will be flammable vapors available, and of course it can catch fire. And certain cautions you can also take while transferring of these flammable liquids or any combustible liquids. So whenever you are going to transfer liquids by means of any air pressure or container is prohibited. So of course the high pressure may result the they can catch or like produce like they can produce over expressure, so which could exceed that the container could withstand. And secondly, uh, the flammable atmosphere so could be created in the atmosphere into the container due to the high pressure. Okay, so which can also is sensitive to the ignition of increased pressure. So high pressure also is one of the reason that can cause like ignition. So high pressure of course is to be avoided. This slide is very important to remember always when we are going to handle those flammable liquids after or at the point of final use. For example, if somebody's used flammable or combustible liquids, then it is very important. Of course, we need to understand this is vapors, not like the liquids that burns. Okay, so since these are the vapors, and although the tank like the safety can is empty when we use all these chemicals or the liquids, and since still there are vapors, okay, so the vapors are still inside those the cans, and of course if that vapors the concentration of that vapor is at the between the limit. So, and of course if we did not take care of the empty even cans or the safety cans, even it can, if there is a source of ignition that can introduced, and it can catch the fire because the vapors of that particular liquids will be there and with the source of the ignitions, and it can cause the explosion. So you got my point. This is very important and very practical slides. If we are using any cans, whether we are keeping like in the car for example, or in the kitchen, or sometime like of course in the labs, many cans, so we think this is a finish, like this is empty cans. So since this there are the vapors of the combustible or like flammable liquids are still there, and if there is the introduction of an ignition sources, so it will cause the explosion by the combination, or if the limit is of those vapors are available. The following work practices must be followed when handling flammable or these combustible liquids. Flammable liquids must be in covered containers. So covered containers when not in used. Of course, this is very important, always to cover, because the vapors can go and float into the air. So these liquids must be stored by in acceptable containers. As I mentioned in the last slide, so special containers, not like a normal water bottle, or the soda empty bottles, they are not used. Whenever in future, in your life, in your domestic life even, or in the lab, if you need to use those liquids, and always first check, like the containers. Okay, so don't use if you don't have like the proper container. So where flammable or combustible liquids are used or handled except in closed containers, means shall be provided to dispose of or leak of spill liquid promptly and of course. So after use it, so then properly dispose of, not like dispose of like as we dispose of our normal or the domestic bottles. So these bottles or the empty cans, so should be, or like any containers should be properly disposed of, or not like in the as a junk, because as I mentioned in the previous slide, so due to the vapors, they can also can catch the fire, so due to the static current as well as any other ignition sources. So this is all about these flammable and combustible liquids. I think this is a very small and short lecture, but very important. And if you have any questions, so during discussion, so we can discuss. So thank you so much.